Hello guys, welcome to IBDP. In this video, we are going to solve the free force diagram examples. So if you haven't watched the video of the free force diagram, there will be a link above you. Just click on the link, watch the video and come back to this video. So let's just proceed to our example number 1. So we have to draw the free body diagram of this two mass, that is M1 and M2, which are in contact with each other and they are placed on the ground. Okay, so that means first step is that we have to identify the bodies over here. So that means the bodies, what will be our bodies? Yeah, the bodies will be M1, M2 and the ground, right? In the previous video, I told you that ground will be also considered as a body in free force diagram. Okay, so now that we have identified the bodies, the next step was to isolate the bodies. Okay, so that means first of all draw neatly the bodies isolated. So this is our mass M1, this is our mass M2, right, and this is our ground, right? So that means what? We have successfully isolated the bodies, right? Okay, so that means step number 1 is done. Step number 2 is also done. So let's just proceed to step number 3. So that means we have to identify now which surfaces are in contact, right? So that means I can argue you that the lowermost surface of mass M1 is in contact with the uppermost surface of the ground, right? So that means surface 1 and surface 2 are in contact, right? I can tell, obviously. Similarly, what will happen? That the lowermost surface of M2 is in contact with the uppermost surface of the ground, right? Why? Because both M1 and M2 are sitting on the ground. That means they are in contact with the ground, right? So that means surfaces 3 and surface 4 are also in contact, right? Similarly, what will happen is that, see, over here I can also tell that the two blocks, that means M1 and M2, are in contact with each other. Why? Because they are standing next to each other, right? So that means they are in contact. So that means the rightmost part of M1, okay, so my bad, this is a big ink. So that means the rightmost surface of M1 is in contact with the leftmost surface of M2. Okay, I also can write that. So that means I can write this surfaces 5 and surfaces 6 are also in contact. Okay, so that means what we have to do now is that we have to write the surfaces in contact first. So that means surface, I'm just replacing surface with sir. Okay, surfaces 1 and surface 2 are in contact, right? So that means what will happen? Surface 1 will give a force towards surface 2. Why? Because they are in contact with each other, and when surfaces are in contact with each other, they give forces to each other. So that means they will be N1. The value of that force is N1, suppose. Similarly, what will happen? Surface 2 will also give an equal force, but in the opposite direction. That means surface 2 will give towards surface 1 the same force N1 by Newton's third law of motion, right? So that means over here N1 and in the downward direction also N1. Okay. Similarly, what will happen? Surface 3 and surface 4 are also in contact, right? So that means surface 3 will exert a force towards surface 4. Let the value of that force be N2. Why surface 3 giving a force to surface 4? Because they are in contact with each other. Okay, so that means by Newton's third law of motion, surface 4 will also give a force towards surface 3, right, in the opposite direction, right? Because every force has an equal and opposite reaction. Since 3 is giving force to 4, 4 will also give a force to 3 in the opposite direction, right? So that means this will be our N2 in the downward direction produced by 3 on 4, and this will be our also N2 produced by 4 on 3. Okay, so now again we have seen that surface 5. Okay, so let me write this as surface. So surface 5 and surface 6 are also in contact, right? So that means surface 5 will exert a force towards surface 6 because they are in contact with each other. Suppose the value of that force be N3. Okay, similarly what will happen by Newton's third law of motion, surface 6 will also exert the same force, that is N3, but in the opposite direction to surface 5, right? To surface 5. Okay, so that means over here this will be our N3 and this will be our N3. Okay, so that means we have successfully identified all the surfaces in contact and given their respective forces. Any more surfaces are in contact? No, right? You can still elaborate and think about this, but there are no surfaces more in contact. Okay, so that means we have finished the contact forces first. Now what will be the non-contact forces? So we have discussed in the video that the non-contact forces will be the weight of the body, right? So that means over here the non-contact force will be what? M1g downward, and over here the non-contact force will be how much? M2g downward, right? So that means we have successfully completed the 3 steps. Now what is step number 4? Step number 4 is to draw a neat diagram. Why? Because see, this diagram has become messy. Okay, so that means if I just rub this, I can draw a neat diagram. So for M1, so suppose this is the M1 block, right? Over here downward our force will be N1 and the weight of the block will be how much? M1g downward. Okay, so let's just write me this with this. Okay, so for the next block, no, sorry, my bad, over here this will be also N3 in this direction, right? Because I'm just drawing this block only. Okay, so that means proceeding towards M2, on M2 from downwards, that means from the ground there will be N2, downward will be our M2g, and over here will be our N3. Okay, and now for the ground, so the ground will be, so this is our ground. Let me decorate the ground first with stripes. So that means on the ground over here will be our N1 and over here will be our N2. So now what you can do is that you can combine these forces, right? Because N1 and N2 are applying in the same direction, right? So we can combine these forces and tell it to be a single force, right? So we can combine these two forces and tell it to be a single force on the ground, that will be N1 plus N2. So I hope you got the example. Okay, so in the next example we have a wedge of mass M2 which is having an inclination theta. Okay, and over the wedge there is a block of mass M1. So again follow these same exact steps. Okay, so first of all we have to underline the bodies, right? So what are the bodies? M1, M2 and ground, right? So I have told in the previous video also and in the previous example also that the ground will be also treated as a body. Okay, so now we have just successfully written down the bodies. The next step is to isolate the bodies. So we have to isolate the bodies. Okay, so that means this will be our ground. So this will be just a second. So this will be our ground, and over the ground will be our wedge, right? So that means this will be our wedge. this will be our wedge. Okay, the mass of the wedge is m2, inclination is theta, and over the wedge in this manner, my bad, sorry, and over the wedge in this manner is our block of mass m1. Okay, so now we have successfully isolated the bodies. Okay, so now we have to know the surfaces that are in contact. Okay, so that means I can argue that the lowermost surface of m2, so that is surface 1, is in contact with the uppermost surface of the ground, surface 2, right? Why they are in contact? Because m2 is sitting on the ground, right? Similarly, I can also tell you that the lowermost surface of m1 in this direction is in contact with the uppermost surface of m2 in this direction, right? Because these two surfaces are in contact. Okay, so suppose this be surface 3 and this be surface 4. So that means, so let me just write the surfaces that are in contact. Surface 1 and surface 2. Surface 1 and surface 2 are in contact. Also, surface 3, that is the lowermost portion of the block of mass m1, and surface 4, that is the wedge, right, are in contact also. Okay, so that means for surface 1 and surface 2, so that means surface 1 will exert a force towards surface 2, and the value of that force will be how much? N1, right? Why they are exerting forces? Because they are in contact with each other. Similarly, by Newton's third law of motion, surface 2 will also exert the same force but in the opposite direction on surface 1. So that means the value of that force will be also N1. So over here the force will be how much? N1, and downward also the force will be how much? N1. Okay, so now on surface 3, right, surface 3 will exert a force towards surface 4, right, and the value of that force will be N1. Okay, so that means see that surface 3 is in this manner, right, and surface 4 is in this manner, and surfaces exert force only in the perpendicular to the surface. Okay, so that means if this is the surface, the force will be exerted perpendicular to the surface. So that means surface 3 will exert force on surface 4 perpendicular to its surface. So that means in this direction will be our N2. Okay, so my bad, this will be N2 because N1 is already taken. Similarly, what will happen? Surface 4 will exert the same force on surface 3 but in the opposite direction. Why? By Newton's third law of motion. Okay, again also see that the surface 4 is in this direction, right, in this manner. So that means it will exert a force in its perpendicular direction, right? So that what is its perpendicular direction? Yeah, in this manner. Okay, so that means surface 4 will exert a force on surface 3 and 2 in this manner. Okay, so I hope you got this. The main gist is that, or the main concept is that the force exerted by one surface on the other is always perpendicular to the surface. Okay, so that means that's why the direction of N2 is in this direction, Okay, now all the surfaces has been identified. Okay, so now all the contact forces also has been given. So that means we are now left with to give the non-contact force. So what is the non-contact force? The weight we have discussed in the previous video. So that means the weight of the body will be m2g downward, and over here the weight of the body will be how much? m1g downward. Okay, so all the forces has been shown, all the three steps has been performed exactly fine. So now the next step and the final most important step is to draw a neat diagram. Okay, so that means for M2, so that means this is the block of mass m2. Over here in this direction there is the force, how much? N1. Downward direction there is the weight, that is m2g, and in this direction there is how much? N2 produced by surface 4 on surface 3. Okay, on the ground, so on the ground the net force is N1. Over here the net force is N1. Okay, and for the M1 mass, so that means this is the N1 mass. Okay, so this has a mass M1. Over here the this will be how much? This will be our N2. Okay, and the weight of the body mg will be acting downwards. See, the weight of the body will not act perpendicular to the surface. The weight of the body always acts downward. If you rotate the object, it will always point towards downward. Okay, so that means the weight of the body will be pointing downwards. Okay, so m1g. So I hope you got this video, and these are very good examples of free force diagram. We'll be solving many more examples with tensile forces and all. So do subscribe and hit the bell icon. Thank you for watching. Stay safe.